Units are our means for distinguishing quantities of different things that we're measuring. Units distinguish between different things. We have to distinguish between volume and mass and length and all of these. Just having a number tells us nothing. The number 3 is irrelevant. However, having 3 milliliters or 3 liters does tell us something about our measurement. A unit will convey information. And there are 3 basic systems. There is the imperial system, the English system that you use for units. There is the metric system. And there is the SI system. The imperial system is used in the United States primarily. It has some application outside of the United States, but it's not greatly used. The metric system is used throughout the world. What the hell? Metric system is used throughout the world, but is less complete than the SI system. The SI system, or the Système International, is a scientific system, but because its units are not all entirely agreed upon, it isn't used as widely as the metric system is. For the purposes of our course, we'll use the metric system primarily. The English system, used in the United States, is a random collection of different units. You have things like pounds, yards, gallons, and their conversion between. The metric system, on the other hand, uses powers of 10 to relate their units. What we basically do with the metric system is we have a base unit for whatever value we're measuring, like a gram for mass or a liter for volume, and we'll use a prefix to indicate the number of base units we have. So if we look at these prefixes here, the prefix mega indicates 1 million base units, so 10 to the 6th base units. The prefix kilo is 1,000 base units. Deca is 10 base units. Deci is 1/10 of a base unit. Centi is 1/100th of a base unit. Milli is 1/1000th of a base unit. Micro is 1/1,000,000th of a base unit. And nano is 1/100,000,000th of a base unit. And there are others besides this. So the way that the metric system works is we'll append the prefix to the base unit depending upon what we're measuring. So things like mass will be measured in grams generally. We've got milligrams, which is 1/1000th of a gram, or decigrams, which is 1/10 of a gram, or decagrams, which is 10 grams, etc., that kind of thing. Volume is measured in liters, generally, so we have milliliters as 1,000th of a liter, or deciliters as 1/10 of a liter, or decaliters as 10 liters. Length is in meters, so you guessed it probably. A millimeter is 1/1000th of a meter, a decimeter is 1/10 of a meter, and a decameter is 10 meters. Now, converting between different units within the same system are using conversion factors, which relate the 2 units to each other. So 1 centimeter is 10 millimeters. 1 millimeter is 1/10 of a centimeter. We transform these ratios into fractions to use them as conversion factors. So for instance, we know that a centimeter is 10 millimeters. A millimeter is 0.1 centimeters. And we set up the ratios to relate to base units. So the way that we would come up with these conversion factors is take the exponential from the table. Like for instance, we know that mega as a million is 10 to the 6th. We flip the sign from what it is in the table and then plug it in. If I want to convert 10.5 kilograms to centigrams, for example, I know that kilo is 10 to the 3rd on that table, and centi is 10 to the minus 2 on that table. So I would convert so that 10 to the 3 becomes 10 to the minus 3, and 10 to the minus 2 becomes 10 to the 2. I set up my conversion factor. I put what I start with on bottom and what I want on top. So if I'm converting from kilograms to centigrams, I want centigrams. I have kilograms. I put the centigrams on top and the kilograms on bottom. So centigrams over kilograms. I plug in the values, and then I can use it. So we look here, we have 10.5 kilograms times 10 to the 2nd centigrams per 10 to the minus 3 kilograms. If we take 10 to the 2nd divided by 10 to the minus 3, that comes out to 10 to the 5th. So our conversion factor is 10 to the 5th centigrams per kilogram. So we have 10.5 kilograms times 10 to the 5th centigrams per kilogram, and just like in math, my units of the same type cancel out, so the kilograms are eliminated, leaving us with 1.05 times 10 to the 6th centigrams, or 1,050,000 centigrams. Experimental quantities that we measure in chemistry are things like mass. Mass is the amount of matter in a substance. we measure mass in grams generally. But on an atomic scale, a gram is a really, really, really big value. Our atoms are tiny. So we actually use a different measure of mass for our atoms, a measurement called the atomic mass unit. The atomic mass unit reflects 1.661 times 10 to the negative 24 grams. Length is literally the distance from point A to point B and is generally measured in meters. Volume is the space that is occupied by a substance, and we measure that in liters. But a liter is almost the size of a quart. It's a big unit. So oftentimes in laboratory settings, we'll use a milliliter or a cubic centimeter instead. A cubic centimeter is equivalent to a milliliter. Now, looking at the different apparatus that we use, or the apparati that we deal with, their graduations may differ depending upon their utility. A instrument which is designed to measure only one single particular volume may have very, very, very high precision. But an instrument that can measure multiple different volumes probably has lower precision. Time is a measure of event ordering in a situation. And so when we measure time, we generally measure time in seconds, which are abbreviated S or ACC. Concentration we'll talk a lot more about later, but concentration basically measures the amount of something per unit of something else. Now, density is a common value that we take measurement of, but it's not actually a measurement in itself. It's a value that relates two different values to each other, and it relates the values of mass and volume. So density is really the amount of space occupied by a particular mass of a substance, and we represent density using either the Greek letter rho, which is what you see first. It looks kind of like a funny P, or D, capital D, either way. And the formula for density is mass divided by volume. We measure density generally in either grams per cubic centimeter or grams per milliliter. And so, for example, if I wanted to calculate the density of a 2 cubic centimeter sample that had a mass of 5.40 grams, I would take 5.40 grams, divide by 2 cubic centimeters, and I get 2.70 grams per cubic centimeter. Now, another measurement that we have is called specific gravity. Specific gravity is an interesting thing used to tabulate data, and it simply relates the density of a sample versus the density of water. The density of water at 25 degrees Celsius is 1. So what it really is doing is taking a density and just eliminating the units.